One of my first Arduino project was controlling a LED with a single button. My name is Tibi and welcome to my workshop. In this video I'll explain what went wrong and I'll show you a solution to the problem. The idea was when I push the button, the LED stays on, and when I push it again, the LED stays off. Sounds simple? Well, I thought the same, but it wasn't. Because of erratic button behavior, my little project didn't work reliably. This was due to electrical bouncing noise that occurs when you push or release a button. When pressed, current bounces up and down before it settles to its final resting position. I used a simple logic analyzer to observe this phenomenon. On this picture, you can see the current bouncing, and it takes almost 1 millisecond for the signal to settle. There are several hardware or firmware solutions to this problem. Using a capacitor in a parallel with a pull-down resistor would be one of the hardware solutions. You can also use a library for Arduino environment that deals with this issue and include it when your project involves a push button. In this video, we will be looking at a firmware solution without using a debouncing library. The wiring is simple. When the push button S1 is released, it's bringing the ground or logical 0 through a pull-down resistor to Arduino's digital pin D2 set as input. When the button is pushed, we bring 5 volts or logical 1 to the input pin. One side of the LED, anode, is connected to Arduino's digital pin D8 set as output. The other side, cathode, is connected through a protective resistor that reduces the current to a safe level to avoid burning the LED. We begin with declaring and defining variables. Our LED is connected to Arduino's pin number 8 and the button is connected to pin number 2. We know that these values will not change during this project, so we can declare them using a fixed variable type called #define and naming them as LED pin with a value of 8 and button pin with a value of 2. Defined constants don't take up memory space. This means that when you hit the Arduino IDE upload button, the compiler searches for all the LED pins and button pins in the sketch and it replaces them with respective values, 8 for LED pins and 2 for button pins. In the line 3, 4, 5, we declare and define Boolean variables for the button and the LED states. As you might know, Boolean variable types can store true or false values, but you can also replace them with high or low, or 0 or 1. All of these refer to on or off state. In the line number 6, we create a variable with a value of 5 milliseconds. You can change this value, but 5 milliseconds should be enough to wait for bouncing to finish. In the setup function, we set the LED pin to output and the button pin to input mode. Moving on to loop function, the line 14 we trigger a debounce function and send all button states value to it. So let's jump to line 22. In the line 22, the debounce function takes in a value of all button state and assigns it to a declared Boolean button state variable. In the line 23, we read the button pin's value with digital read function and we check if the button is pushed or released. This value is then assigned to a newly created Boolean current button state variable. In the line 24, the if statement compares if button state is not equal to current button state. If the condition is true, we move to the line 25, where we delay the process by 5 milliseconds, and in the line 26, we read the button pin's value again, assuming that the button finished bouncing. If the condition is false, lines 25 and 26 are skipped. In the line 28, we return the value of current button state to the calling function. Now that the debounce function finished, we go back to the loop function in the line 14. The variable new button state takes the value returned from the debounce function. In the line 15, the if statement compares if old button state is equal to low and at the same time if new button state is equal to high. If the condition is true, in the line 16 we invert the value of LED state. If the condition is false, the line 16 is skipped. In the line 18, we assign the value of new button state to old button state. In the line 19, Digital write function writes LED states value to the LED pin. This is where we switch the LED on or off based on LED states value. After this, the loop function goes back to the beginning and starts again. I hope this comes in handy. Give it a thumbs up if it does. If you got any questions about this video, please let me know in the comments below. And make sure you subscribe to TB Online for more videos. Thanks for watching. Cheers.